For years, the technology sector treated AI ethics as an academic exercise. In 2026, that grace period expired. Global regulators have abandoned voluntary principles and moved directly to aggressive, real-world enforcement. This shift was driven by the accumulation of concrete, measurable damages. AI systems repeatedly produced heavily biased algorithmic outcomes in housing and credit, while synthetic political media eroded the integrity of public information networks. The turning point occurred when deepfake voice fraud began targeting high-profile political figures, such as Senator Amy Klobuchar. When synthetic audio of a sitting lawmaker spewing vulgarities circulated online, the threat transformed from a distant technical concern into an immediate legislative panic. The fallout from these public failures produced an immediate reaction: a wave of class action litigation, intense consumer backlash, and sweeping crackdowns from enforcement agencies demanding accountability. Operating an opaque black box algorithm without strict oversight carries existential risk. Mechanical, verifiable compliance is now a strict requirement for corporate survival. In the United States, attempts to pass a comprehensive federal AI statute stalled completely. The administration's fallback strategy relied on executive actions to preempt state laws, leaving a massive gap in statutory authority. Nature abhors a vacuum, and so does the legal system. Individual state governments aggressively filled that void, enacting a chaotic patchwork of disjointed privacy and consumer protection laws to police algorithmic behavior. Beyond American borders, the legal landscape looks entirely different. Massive global markets, notably the European Union and China, implemented highly structured, unified technological mandates with zero tolerance for ambiguity. This creates an intense operational dilemma for software engineers. A single multinational AI model must be deployed across networks that enforce completely contradictory legal architectures. To deploy software globally in 2026, organizations must master two radically different enforcement mechanics simultaneously: U.S. proxy enforcement and Chinese technical governance. The American legal strategy relies on regulation by proxy. Instead of drafting new laws to regulate complex source code, regulators prosecute the algorithm's final output using existing civil statutes. This diagram illustrates why state attorneys general favor this approach. Rather than litigating billions of opaque neural weights, they allow the model to make a decision. If that decision hits a barrier of established state law, the company is liable. The specific weapons of choice are existing consumer privacy laws and anti-profiling statutes. These laws restrict automated decision-making processes, giving regulators a ready-made framework to scrutinize high-risk systems. Enforcement actions focus heavily on procedural failures. If an AI system operates without clear consumer notice, or if its required opt-out mechanisms are broken and inoperative, the state will issue fines. Regulators also heavily target the aftermath of harmful outcomes. Producing a discriminatory result is a violation, but trapping consumers in an ineffective or illusory appeals process guarantees a severe regulatory response. For example, if an AI mistakenly flags a student's backpack as a weapon, the state does not audit the computer vision model. They file a standard consumer protection lawsuit against the deployer for delivering a dangerous, unverified product. U.S. enforcement risk ignores the underlying mathematics. Liability hinges entirely on output management, consumer transparency, and the ability to legally defend the final result. China's regulatory framework, spearheaded by the Cyberspace Administration, operates on a completely different premise. They utilize direct technical governance. This mandates that structural legal compliance must be engineered directly into the AI's core architecture before it ever interacts with a user. This pipeline schematic demonstrates the content labeling measures. When a Chinese AI generates an image, the system must automatically apply an explicit visual watermark to prevent public confusion. Simultaneously, the system executes an implicit tagging protocol. It injects machine-readable metadata directly into the file's hidden layers, permanently embedding the service provider's code and a unique content identification number. The hurdles begin long before deployment. Developers must complete an algorithm security self-assessment and formally file their system in a strict national algorithm registry. This national registry is not just a paperwork exercise. It requires companies to grant state regulators direct API access, meaning an application programming interface connection, so authorities can actively test the model's functions and security. Unlike the American focus on final outputs, Chinese compliance demands total state visibility, requiring developers to inject legal protocols directly into their codebase. China's Personal Information Protection Law implements a massive pre-training constraint known as a PIPIA. PIPIA stands for Personal Information Protection Impact Assessment, a legally binding evaluation of data risks. This assessment is triggered the moment an organization attempts to process sensitive material, such as feeding raw biometric voice prints or facial scans into a generative template. The timeline is absolute. The PIPIA must be completed and documented before a single byte of personal data is used for model training. The judicial consequences for skipping this step are severe. In the civil case of Liao v. Technology and Culture Co., a Chinese court ruled that collecting facial data for an AI face swap template without prior consent and assessment explicitly violated personal information rights. Bypassing these architectural steps in China guarantees judicial liability before the AI even finishes compiling, let alone generates its first output. When an enterprise attempts to scale a single model across these global jurisdictions, the sheer density of the legal code creates an operational crisis. Overlapping and frequently incompatible legal requirements bombard the deployment simultaneously. A single user query might invoke California's profiling bans, the EU AI Act's risk standards, and China's data localization rules in the same millisecond. The volume of third-party contracts, API access logs, and data retention schedules required to prove compliance scales exponentially with every new active user. At this density, manual spreadsheet tracking and human auditing have mathematically exceeded operational capacity. Relying on traditional, manual compliance methods is now a severe organizational liability. They are too slow, producing the exact enforcement gaps and audit failures they were designed to prevent. To maintain legality at machine speed, organizations must deploy specialized AI tools to monitor their own generative AI systems. This requires a modern GRC platform. GRC stands for Governance, Risk, and Compliance, specialized software that provides continuous monitoring, automated control mapping, and real-time regulatory tracking. These systems execute contract-level analysis against varying global frameworks simultaneously. They scan active agreements and automatically highlight missing data protection clauses or non-compliant indemnification terms. By utilizing predictive risk scoring algorithms, these tools evaluate historical anomalies and flag architectural policy deviations long before enforcement deadlines arrive. Surviving the 2026 legal landscape requires an automated compliance stack capable of operating at the exact speed and scale as the artificial intelligence it governs. The reality of 2026 is uncompromising. Organizations must navigate proxy lawsuits in the United States and strict algorithmic audits in China at the exact same time. In the US, this requires intensely mapping every AI use case against overlapping consumer privacy laws to guarantee that output rights are legally defensible. In China, it requires engineering technical transparency, mandatory metadata logging, and strict algorithm explainability directly into the deployment pipeline. Legacy companies make a fatal error when they treat these global regulations as post-release legal hurdles, rather than treating them as core engineering constraints from day one. The division between legal departments and software engineering teams must be eliminated. They are now required to operate as a single, unified architectural unit. This structured network represents the baseline for international operation. To move data across borders, the architecture must be flawless. The ultimate requirements for global deployment are absolute. Design for transparency, engineer for auditability, automate for scale. The penalties for failure are multi-jurisdictional fines, heavily restricted models, and in the worst cases, forced algorithmic destruction. In 2026, the organizations that dominate the market will be those that transform regulatory compliance from a defensive legal strategy into a foundational engineering advantage.